In this video, I will be explaining how you can use inverse indexes to make a search engine much faster than a brute force search engine. So as you probably have experienced, whenever you want to search for a file on a computer, and you type in the search bar in Finder or Dolphin or Windows Explorer or whatever you use, it takes a very long time to find a document. And the reason that is the case is because it doesn't have a very good search engine. It's probably using brute force or something where it has to check every single piece of anything on your computer to find what you want. So chances are it's going to take a long time. So there's many solutions for this, but one of the easiest ones to implement is called an inverse index search. And while it is not as good as a vector-based search, which is what Google uses, vector-based searches are basically specialized, they're like specialized chatbots for search, so it takes much more resources to make them. So in this video, I'll be just explaining how you use inverse search engine, which is what was used basically until we had the invention of the transformer, 2017. So what you can see here on my screen is a catalog of data about files. This is for Project Gutenberg. You can see here you have a book number, you have text as opposed to the other file types, issued, which is irrelevant, title, very important for each of the books here, language the book is in, and then you have author with the author's life, years he was alive, and then you have different kind of what I call metadata or description, categories, U.S. history, Declaration of Independence, politics, history, whatever. And so you have this for each of these files. And so the question is, how do you search this fast? And so while for the Project Gutenberg database, it's relatively small, so probably anything you use is going to be fast enough. You want something that's fast and works. So you can just type in something like, let's see, if I do localhost. So this is the website I've built for localhost, and I'll show you what kind of search this is able to do. This is entirely offline. I'm going to do a search for Jefferson, U.S. Constitution, and I'm going to do this in strict mode and see what we have. So search, and you can see right away it's a very fast search, and you get the Constitution of the United States, and it looks like I may have misspelled Thomas Jefferson. I'm going to try using Ollama to improve the search, and it may improve our results. Ollama can make things worse, but it will correct spelling errors. So we'll see if that'll take longer because Ollama is taking time to improve the prompt, the search query, and so yeah, that's gonna take some time. So while it's taking its time, I'll explain more about inverse search engines. So this is our raw log of information about the files, but here's how you search it. So this organized everything. So this is about topics, as you can see, inverse index topics. And so the topics are just words from what I call the topics part. So I consider all the stuff after the author to be topics. And some of the topics are just numbers, some of them are like JK or whatever those mean, which I don't know, but that's all what I consider a topic. So I had a program take that data and then convert it into this inverse indexed. So what you can do now is you can just search for words, and if you find the word, it'll tell you all the book IDs which have that word in the description, or in this case, I don't have another catalog if the word's going to be in the title, it's in authors or whatever. And so this is much faster because after all, in the query you have words, and you want to find the books. So this way you can look up, it'll just search for the words, and when it finds the words, it'll rank a list of the books which have that word in the description or the title or whatever. And otherwise, you would have to search through every single book. And so this is long, I will admit. It's not quite as long as the whole Project Gutenberg. It's only 17,000 lines instead of 70,000 lines. So that's significant, but as you get larger and larger, the number of words is relatively finite compared to the number of possible things you can search in a very large database like the internet or Wikipedia or whatever. And so with this, if the word at the beginning of the column is not equal to something in the query, it just moves on. So you get to, like for example here, this is a comma separated value, a CSV, a spreadsheet. But right here, if let's say other is not in the query, all of this data here, you can just skip over it. It doesn't slow down the search process. And so let's see, checking back. Okay, yeah, so in this case, okay, we have some problems for some reason. Oh, I know the problem. The problem is that Thomas Jefferson wrote the Declaration of Independence, not the Constitution. So that's probably why there's not a whole lot which have both Jefferson and the Constitution. So let's say Declaration of Independence. And hopefully I spell it right. If you don't spell it right, that's going to be a problem. I'll just do strict search because it's faster. We'll see what we get. And here we go. Thomas Jefferson, the Declaration of Independence of United States of America. And so as you can see, it works quite well. And so what the search engine is doing is it just goes through each word and it finds which books have that word in their in this, but this is divided up into a collection of inverse indices like this, and then based on how many of the words are found in each of these numbers, the ranking system is a bit complicated, and there's a whole bunch of alternative ranking systems you can use. There's not really any one best ranking system. Conventionally speaking, you pick your own, but this is the power of inverse index search. It's very fast. It scales quite well. And the problems with inverse index search is if you look up, for example, cats, it won't know that felines is related. So that's where I try to use Ollama to like, I'll do an Ollama search, see if that makes any differences. But with the Ollama prompt, what I have under the hood is something like find related words to the query words to expand the search and hopefully give better results. But the alternative is use a vector search, which just requires a lot more work. So this is all there is for today. It's just inverse index search, and it's super fast, and this is how Google worked for the longest time until they had vector search in 2017 on. That's it for today. I hope you like this video, and now you have a better understanding of how search engines work, because as soon as you have to manage large databases, search becomes a critical feature. So if you like this, you can check out, I have AI videos as well. This is all towards AI, because if you want to have retrieval augmented retrieval augmented generation for AI, you need to have a search engine to search a database, and so this is all tied to AI, even though it's not AI strictly speaking. It's a tool you need for AI. So hope this brought you value, and if it did, please consider liking and subscribing. Thank you.